Hey everyone, this is Jason Dinsmore from OrganicChemistOnCall.com. What I'd like to go over in this video is talk about nucleophiles and electrophiles, and I'll probably spend most of the time, if not all of it, talking about nucleophiles. We'll see if we get into electrophiles. And kind of pull off of the principles or the ideas that we've been talking about thus far. We've been talking about or looking at atoms in terms of electrons. So as we've talked about before, I'll just do this really quick. Really all the atoms that we really need to consider in organic chemistry are these right here. Okay, these are going to be the overwhelming majority of what you're going to see, and obviously organic chemistry deals with mainly carbon and hydrogen. Now out of these atoms, if we just want a really quick thing to think about in terms of a nucleophile, what atoms that we look at right here in its normal state, and what I mean by normal state is not the fact that this nitrogen, specifically on the, take nitrogen for example, on the periodic table, but when we actually have it in some sort of form. So nitrogen we know has 3 bonds and oxygen has 2 bonds. That's what I mean by the state. So I pick these specifically. If we have to look at the periodic table and think about atoms that are going to be nucleophilic in their normal state where they've got bonds to them, it's going to be nitrogen and oxygen. And what we're going to talk about is when you have an atom that has a set of lone pairs, meaning 2 electrons that are not participating in a bond, that are just sitting there. In this case, they're neutral. They don't contribute any charge. Those are going to be our nucleophiles. So just remember, nitrogen and oxygen can act as nucleophiles, and they don't have to be charged. So how do we consider this and figure out what atoms can and can't be, let's start here, can and can't be nucleophiles or electrophiles? So if we look at, let's just take carbon, let's say, and let's take oxygen. Actually, let's take, we'll take oxygen as well. H, and we'll just do R. And actually, to make this simpler, let's just put R groups here. Okay, so in terms of nucleophiles, if we have lone pairs, like I said, those can act as a nucleophile, a site where something can go in and attack. And what we always want to think about in terms of nucleophiles is a nucleophile attacks something, which means that it has a pair of electrons that it can donate to something. Since it's attacking, it has to have something already there that it can come in and give it to something else. Okay, so that's why when we have these set of lone pairs on oxygen by themselves, they can contribute, they can add, they can attack to something else. If we have a molecule like carbon, for example, we don't have anything to contribute. Everything is filled. So let's start with oxygen. So if we look at oxygen, we already know this can act as a nucleophile. But if we have a neutral molecule, neutral molecules are not as nucleophilic as, for example, a charged molecule. So if we come in here, and let's say we have some sort of base, and we have a minus charge. And I'll explain this, what this minus charge is later. You actually get to see it when we do this reaction. But I'm just going to simplify it in this case, just put a B minus. So what's happening here, and I'm actually going to elaborate a little bit more, is when you have a minus, it means that that minus is associated with 2 electrons. In the case of the oxygen, we have 2 electrons, but we don't have a minus charge because we have the total of those 6 electrons around the oxygen. What happens when you get a minus charge and you have 2 electrons, which we'll see here in a minute, it means that you have, let's use a very dumbed down terminology, I guess, or not, what is it, scientific terminology. You don't have the right number of electrons around it. So let me show you. So what happens here is this base can come in and pull off that proton. When it does that, these electrons go ahead and grab this. Now hydrogen, we know, only wants to have one set of electrons, or one bond to it. So when this comes in, what we're really doing is we're saying these pair of electrons are coming in and we're going to grab that hydrogen. Okay? Now we're going to do this systematically. That means if this base comes in and grabs that hydrogen, those 2 electrons right there are then going to be used to form the bond. Now we know hydrogen can only have one bond to it, and we know hydrogen, if we look up here, only wants to have, when we have a bond, 2 electrons. It doesn't want to have anything else. So what happens here are these 2 electrons here get pushed onto that oxygen. I guess I can do them in the same order here. So what does that look like? We have R dot dot O. We still have that all together, but now we push those 2 electrons down on there. So what does that do for us? If we go up here and we do our oxygen that's normal, we know that that means we want to have a total of 6 electrons, and our bond would be here and our bond would be there. So we want a total of 6 electrons around it to be completely neutral. So let's count. We have 1, 2, 3, 4, 5, 6. Now we have 7, and I'll just remove this just so we can look at it. If we remove that bond, we have a total of 7. That means we have 1 extra electron. Each electron we can think of that we add to our neutral molecule is a negative charge, or if we subtract one, that's taken away a negative charge. So since we've added one, that's a -1, which now means that initially we had our negative on that base, or the B. Now the minus is on there. So you can see that in order to go from a neutral to a minus, all we've essentially done is added 1 electron that now means that it's associated with that atom. Well, you might say, well, isn't that electron right there associated? That's already here. So right there is what I'm talking about. Isn't that already associated with that oxygen? Technically, yes, but in terms of if we're thinking about charge or formal charge, no. If it's part of a bond, you can think of 1 electron being on one atom, 1 electron being on the other atom. So it's not formally, we could say, on that oxygen. When we get rid of that hydrogen, now it is. So now that electron is really associated with the oxygen. Since it's -1, we've got an extra one, so now that's a minus. So I guess this went in a bit more than what I wanted to. This kind of talks about mechanisms, which I'm going to do a specific video on. But in this case, we can see what we've done here is you can see how the electrons flow. So now in this case, since we have a full charge, we still have our 2 pairs of electrons. But now what we can kind of consider here is we have this pair of electrons right here that is associated with our negative charge. Now that is going to be more reactive than this neutral molecule. Why? Molecules do not want to be charged. They want to be neutral. So in this case, this molecule is going to do anything it can to pick something up so it can get rid of that negative charge and make it neutral again. So in that case, that's why negative is more reactive than neutral. And the same thing goes, I said anything that has a pair of electrons, so that's going to be, we can think of our nucleophilic site. So how would this come into play with carbon? Well, we can do the exact same that we did before. We don't need that anymore. We can just have another base with a minus. That will come in once again. Grab that hydrogen. Since we only want 1 bond, that means those 2 electrons right there are going to come in and attach to our hydrogen. So that means we have to dump those onto the carbon. So everything up here stays the same. We have our 2 electrons. Now those 2 electrons are going to get dumped on there. And if we remember from carbon, write it right here, we want a total of 4 electrons around it. But if we go up here, just get rid of this. I know by now you guys are experts. If we look at this, we have 1, 2, 3, 4, 5. We talked about the fact that an extra electron is a minus, so now our minus is right there. If we follow this along, we've pulled that hydrogen off. We're going to use these 2 electrons that we had on the base, and that's going to form our bond, and now we have a neutral molecule. So now we've got that. So now we can see how we can take carbon, and convert that into what's not nucleophilic on its own. If we pull one of those off, we can take both of those electrons that were in that bond, dump them on the carbon, and now it's a nucleophile. What we'll get into later, and you probably heard in your class, and nucleophiles and bases have very similar characteristics. It has to do with how associated we could say those electrons are to the atom, as well as how big are the groups that are around there. We're not going to get into it now, but I just like to kind of throw things in to kind of get your mind thinking about associations.